let's look at try 9. So yesterday we have covered a bit of connected rates of change. I hope that we all have an idea about what we're trying to do now. Okay, so we are looking at a spherical balloon. Then after that, air is being let out of it at a rate of 300 cm cube per second. Okay, we want to find the rate of decrease of the radius when the radius is 2 cm, and then also for part 2, volume is 36 pi cm cube. Okay, so since air is being let out, okay, the way we will interpret this in this case will actually be that dV over dt will be negative 300 cm cube per second. Okay, then after we want to find the rate of decrease of the radius, so that means we are trying to find dr over dt. Okay, then after that when radius is 2 cm, that means r is equals to 2 lah. Okay, but then they did not give you in this case any function, right? They did not give you any equation, did not give you any formula of sorts. So yeah, how do we make our own? Volume of sphere. Okay, so we make use of volume of sphere because the question says spherical balloon. Okay, so in this case, what's the volume of a sphere? Okay, good. So V equals to 4 over 3 pi r cubed. Okay, so V is equals to 4 over 3 pi r cubed, so we will make use of this formula. Okay, define out what is V and what is R, since the question did not define so. Okay, then after that, we want to find the R over dt, so the idea that we need to have is that the R over dt equals to what? What are the two things? D what? dt over dv. Huh, got such a thing? Try now, dt over dv times what? We need dr over dt, right? So what are the two parts that we need to have?
dv over dv.
Then?
dt over dr.
Huh? Okay. Do we know how to create what are the two things here?
dt over dr.
dt over dr. Like that, is it?
Long. Sorry.
dt over dv.
d.
Wait, no, tell. Cannot, there will be one.
No, then is dr over dv.
Okay, we know that it's surely a fraction, right? Okay, we can see it as a fraction coming. Then after that, we have dr and dt. We need the dr on top and the dt below because we know that these two by right should so-called cancel out. Okay, yesterday we have talked about this unique design of the notation. Okay, so we are told dv over dt, right? So surely this will be dv, and this will have to be dt lah. You understand? Okay, so we will need dr over dv times dv over dt. Okay, so first on dr over dv, we will not be able to have r as the rather we will be able to have, but it is not very convenient for us to actually differentiate. So we will find dv over dr. So that will actually give us 4 over 3 pi times 3 r squared. Right? And then that will give us 4 pi r squared. Okay? So then after that we have already covered about the idea of dr over dv. So now we need dv over dt, which the question has given us to be negative 300. So therefore dr over dt will be 1 over 4 pi r squared times negative 300. And this would simply simplify to give us negative 75 over pi r squared. Okay, so now we want to find the rate of decrease of the radius when r is equals to 2. So when r is 2, okay, we will get negative 75 over 4 pi. Right, to answer the question wants the rate of decrease, right? So therefore the rate of decrease, okay, we see this as negative, alright? The negative suggests a decrease, so it is consistent with our question. So the rate of decrease is 75 over 4 pi cm per second.
Same key.
Okay, that's a bit better.
Why cm cube? Rate of decrease of radius.
Already.
Sorry? The question wants us to give your answer in terms of pi. Any questions?
Doesn't say that I is still allowed to be.
Then what?
dv over dt.
Either will be fine.
Change of volume.
Change of volume.
Rate of change of volume.
Oh, means how much air you use.
Yeah, over dv is the derivation.
Sorry?
Derivative.
Which one? Which one?
dr over dv.
dr over dv, yeah, is a derivative. No? So we have agreed yesterday that this is the same as 1 over dv over dr, right?
And dv over dt is the rate of change of volume.
Yeah, rate of change of volume. Yes.
You have to define the
Yes.
is it like R is radius?
No. Not necessary.
So you have to say so it's common practice to define
Yes. Yeah. Anything?
Depends on dr over dv then you write
No, so I already said whatever that I wrote in green, don't write it in your exam. Okay, just go straight into your.
you went from 4 pi r square just straight away.
Ah, any questions? Okay.
Still got part 2 leh.
Oh, sorry. Thank you. Part 2 is to find out what is the rate of decrease when the volume is 36 pi, right? Okay, so in order to find out what is the rate of decrease when V is equals to 36 pi, but in order to find out what is the rate of decrease, we need the value of R. So we sub in 36 pi into the formula for volume. Okay, then we find out what is the value of R. So R is equals to 3. Alright, then when R equals to 3, we can find out what is our dr over dt. And that will give us negative 25 over 3 pi. So therefore the rate of decrease is 25 over 3 pi cm per second. Yep. It is not a coincidence. Yeah. It is how we actually derive the formula in the first place. Yeah. Okay. Good observation. Right. When you differentiate the volume, you will get the surface area of a sphere. Okay. It is actually consistent with understanding of certain things. of decrease of, because we're trying to find rate of decrease of the radius. So cm per second, radius is cm. By the way, remember to submit your assignment, the PRWC question to Jun Xiang by today. Okay, let's look at this question. Right, this question is talking about a boat is being pulled to the dock, okay, by a rope attached to a pulley on the dock. Okay, it says that the vertical distance between the pulley and the boat, okay, is actually 3 meters. So this distance itself is 3 meters. Okay, and then after it says that the rope is shortened at a rate of 0.75 meter per second. So that means it is this distance over here that is being shortened. Okay. And then after that, how fast is the boat moving when the boat is 7.5 meters from the dock? Okay, so we want to know how fast is it moving, okay, towards the dock, right, when it is actually 7.5 meters long. Okay, so this length over here, right, is the same length as on top. Okay, these two lengths are the same, right? What shape do you notice in this diagram? Okay, you notice a right angle triangle, right? Okay, so likewise, this question also has no function given to you. So we need to actually be able to decipher what is a suitable function to use. Okay, because the things that have been described to you, right? Okay, it is mainly around this thing, and this thing. Okay, so we realize that this is a right angle triangle. So we will likely have to use our Pythagoras theorem. Okay, so that is a function that we will need to use. But then, how do we actually use our Pythagoras theorem in this case? Right? So let's just define certain functions. Okay, let us define this to be S and then this to be H. Okay, so let the length of rope be H meters and horizontal distance be S meters. Okay, so therefore in doing our Pythagoras theorem, right, we will have 3 squared plus S squared equals to H squared. Okay, so in other words, H is equals to square root of 3 squared plus X squared. Okay, because H is a distance, surely we will not be using the negative one. That's why we will only be using the positive square root, okay, of the formula. You understand what I'm saying? Okay. So let me simplify this. This will be 9 plus S squared. Okay. So looking at the question again, the rope is being shortened at a rate of this. So this tells us that dH over dt, it is being shortened, so that will be negative 0.75. Okay, because it is being reduced. Okay. So intuitively, right, we tend to see lengthening or lengthening as positive. Okay. Then after shortening as negative. Okay, then after that, we want to find out how fast the boat is moving. Okay, so what will give us how fast this boat is moving? Over time, right? Okay, but then what is the change in the distance that will describe to us this distance, how fast the boat is moving? we will look at the horizontal distance, right? Okay. So actually what the question is asking, we will be looking at ds over dt. Okay, that is how we usually describe how fast, alright? Okay, whenever we talk about, this person run very fast, we talk about the distance that he has moved over flat land, over horizontal distance. We don't describe what is the vertical distance, okay, to describe his speed. Okay, so we want to find ds over dt, alright, when the value for s is 7.5 meters. Okay, so this is what we want to find. So in order to find ds over dt, okay, we need to have understanding that what are the things that we need to multiply in order to get ds over dt. So what are the two things that we need? Okay, ds over dh times dh over dt, right? So dh over dt, we already have it. Okay, we need to know what is ds over dh. But then based on the function that we have over here, it is in terms of h. So we will differentiate with respect to s. Then after that, we just do the reciprocal. So dh over ds is actually s over square root of 9 plus s squared. Okay, and then after dh over dt is really given, so we can now find out what is ds over dt. So that will actually be the reciprocal. In other words, we can flip the fraction times negative 0.75.